Today we're going to do roots, the type of roots and the number of roots. The first thing is the number of roots are always by the exponents. There are two of them. The type are they real or imaginary? Real roots are ones that cross the x-axis. So if you look at this graph, it crosses the x-axis. So we know we have at least one real root. We could have more than that. If it doesn't, we could have imaginary. So what we want to do to find that is there are two roots. So we determine the number of roots. And now what we want to be able to do is factor this trinomial. So factoring it gives us x plus 3 equals 0. And then we solve for each x. And then when we do that, we get a -3 and we get a -3. They repeat, but it's still two roots. It just happens to be the same number. So the type of roots are real because they are on the x-axis. And it happens to be the same number. So they're real roots, and there happen to be the same number, -3. So now let's look at this problem. We want to determine the number of roots. So the answer is 3 roots. And that comes from the exponent. So there are 3 roots. Now what we want to know is, are they real? If you look at this graph, there's at least one real root, maybe 2 if it's the same number. So let's solve this by going through by factoring. So we have x cubed plus 25x equals 0. So first thing I have to do is do greatest common factor. So I get x squared plus 25 equals 0. This cannot be factored anymore, so now we set each one equal to 0. So each factor gets equal to 0, and we solve for x. So in this case, this one's already solved. That's real, so that answers the question. We have one real root. Then the next thing we will do is solve this equation. So when we solve this equation, we take the square root, and we end up with x being, and we have a negative radical sign. So that's I, and 25 is 5. So we have 5i, we have a plus and a minus. Anytime we take square root, we have a plus minus. So because we have the letter I, and there's 2 of them, we have 2 imaginary roots. So we have 1 real and 2 imaginary, which answers our question. If we go back up here, we have 3 roots. So 3 roots, 1 real, 2 imaginary.